Assalamu alaikum and welcome back everyone. I hope you're enjoying this lecture, and today we're going to be talking about our next unit, which is about chemistry. So like I introduced it yesterday, we're doing complete chemistry for Cambridge Secondary 1. Okay, so let's start. Today we're going to be talking about boiling, evaporation, and condensation. So our objective in this lesson will be to name the changes of the state involving liquids and gases, and explain changes of state using ideas about the particles. So we'll be learning about these 2 points. If you like, you can note them down. Okay, so let's start with changing states. When a substance changing from one state to another, its particles don't change. Okay, so when one substance, for example, if water is ice, right? If you freeze it, it's ice. So if you change ice if you melt it, it turns to water, right? So the particles and the state doesn't change, right? It doesn't change. The particles don't change because it's the same. It's just changing from one substance to the other one. All that changes is the distance between the particles. So the particles' distance changes, not the particles, because in water, the particles are far apart. Not far apart like in gas, but are touching each other, but are a little far and are not in order. And in solid, they're in a straight order and are joined together. So the particles just change the distance, and they don't change the particles don't change. Okay, so the attraction between them also changes. So the attraction, for example, the solid particles attraction is very much than the gas and liquid, right? The particles are more attached instead of liquid and gas. So they change. Okay, over here I have made this table for you to understand. As I was telling, ice is solid. So, wait, let me zoom it for you. Okay, so ice is solid. When it melts, it turns to water, which is known as liquid. Then, when we boil water, it changes to steam, also known as gas. When steam condenses, like the water vapors in these clouds, when they condense, they turn back to liquid. Then, the rain comes, right? After the rain comes, if we freeze the water, what we get? Ice. So this is a whole process, and the particles don't change it. Only the distance and the traction between them change. Okay, changing states. Now over here I have another one of the I have another one of the stem chart. Okay, so I'll be showing you over here like how it happened. It's just like the previous one, but it's a bit more easy to understand. So over here, let's start with melt. Okay, so ice. Ice is solid, right? I have written it in points to make it more easier. So when ice melts, what we get? We get water, right? Then when we boil water, it evaporates and turns into steam, right? After steam, when we condense it, it turns back to water, which is liquid. Then when we freeze water, it turns back to ice, which is also known as solid. Okay, so during evaporation, particles leave the liquid surface. When a liquid is boiling, the bubbles of a gas form throughout. So when the particles are boiling, the bubbles are throughout the area. But when their evaporation is going on, the particles are leaving. They're escaping, like they want to run away. Okay? Now let's talk about the next one, liquid to gas. When liquid becomes a gas, the particles move faster and spread out. So when the liquid will turn into gas, the particles will move faster because the gas particles are far apart than the liquid ones. The attractive forces between the particles become very weak. So the attractive force is very weak because the particles are far away, and attraction means particles together, right? So the particles are not together, they're far away. Then a substance in the liquid state becomes a gas by evaporation or by boiling. So the substance in the liquid state, when the liquid state is there, the substance becomes gas. by evaporating or by boiling. Both options are there, by evaporating or boiling. Then evaporation. Let's talk about evaporation. Okay, so evaporation happens when particles leave the surface of a liquid. So many of you have seen this, that when we boil water, the water starts to if we put a bucket of water on heat, the water starts to evaporate, right? And then there's no water left in the pan. That's because that the particles are leaving the surface. They're leaving the surface on the pan, and then they're flying up because of the heat. So the particles spread out to form gas. They turn into gas because the heat over there is making them evaporate. Then evaporation can happen at any temperature. So it can happen at any temperature below 0, below 10 or 0, because evaporation happens at any temperature at any time. Below 0 as well. I'm wrong. Below 0 as well it happens. Many, like nitrogen as well, evaporation can happen below that as well. So over here we have boiling. Okay, so boiling occurs through the whole of a liquid. When you heat a beaker of liquid water, bubbles of the water in the gas state form throughout the liquid. The bubble rises to the surface and escape. The water is boiling. Boiling can only happen when a liquid is hot enough. So over here, to tell you and summarize it, it means that boiling occurs when the liquid, through the whole liquid, boiling occurs when there's liquid, and small particles start to come, like bubbles. They start to come over the pan. It means the water is being boiled, and it is reaching over too much heat. That's why the particles boil. They don't evaporate. Okay, now let's learn about boiling point. Boiling point and boiling is different. So different substances boil at different temperatures. The temperature at which a substance boils is its boiling point. So when a substance boils at one boiling point, there are different types of boiling point for each substance. Okay, every substance has its own boiling point. As I mentioned over here, every substance has its own boiling point. Okay, so here is a chart of here's a table I have written. So there are different types of boiling points. Like I have used the substances nitrogen, mercury, ethanol, water, copper, and diamond. So the boiling point for nitrogen is minus 96 degrees Celsius. Okay, I am not using Fahrenheit over here. So minus 196 degrees Celsius. Wow, that's really low, right? In a mercury, 357. Wow, that's really above the heat. Ethanol, 78. Water, 100. Water is very common, I guess. Everyone knows that the boiling point of water is 100 degrees, right? So copper, 2595. Wow, that's so much heat. Now diamond, OMG. The diamond temperature is really high. Wow, the boiling point is amazing for it. So diamond must be really hard to be boiled, right? Because many industries can't do it because the boiling point is too much for it. Okay, so nitrogen has the lowest boiling point of the substance in the table. Diamond and copper have very high boiling points. So over here, as I just told you right now, nitrogen has the lowest boiling point. Wow, that's shocking, right? Okay, over here I have used a table. Okay, so measuring boiling point. Mibsy has a colorless liquid. So I just gave a name, Mibsy. Okay, he has a colorless liquid. Then let's see. He knows that the liquid is either ethanol or water, but does not know which. Then, to find out, Mibsy uses an electric heater to heat the liquid. Then, he measures its temperature every minute. He plots the data on the graph. This is the graph over here I have given you. The graph shows the temperature of the liquid increase for the first 5 minutes. Okay, the liquid is increasing till the first 5 minutes, right? Over here, as you can see, it's increasing till 5 minutes. Then the temperature stayed at 78 degrees Celsius for 3 minutes while the liquid boiled. The boiling point for the liquid is 78 degrees Celsius. So I told you behind as well in the table, as if you had seen it. Wait, let me show you. Yes, the table. Which one is 78? Ethanol, right? Between ethanol and water. So the boiling point of ethanol is 78. So over here they have showed us that the boiling point is 78. So ethanol must be it, because then the boiling point, what it happens, instead of evaporate, it starts to evaporate because the boiling point has reached at the last minute. So 78 was the boiling point. This was just an example. The data in the table shows that the liquid is ethanol. The answer is ethanol because the ethanol's boiling point is 78 degrees Celsius. Okay. Gas to liquid. When a substance changes state from gas to liquid, the particles move more slowly. So over here they say when the substance is changing from gas to liquid, not liquid to gas, the gas to liquid, the particles move more slowly because the distance between them is very little. Okay, they get closer until they touch each other. They start getting closer and start touching each other because in gas, the particles are far apart, and in liquid, they're medium, right? So then they start touching each other. The forces between the particles are much stronger in the liquid because in the liquid, the particles touch each other more than in the gas, right? A liquid becomes a gas by condensation. So a liquid will turn into gas by condensation. A substance in the gas state condenses when it cools to its boiling point or below. So the substance in the gas state will condense when it is cooled or when it is boiled, when the boiling point is below. Okay, is it on its own boiling point? Like for gas, or for gas, nitrogen is a gas, so minus 198, I think. So it will start cooling down at this boiling point or even at below. Okay, trick questions. Now I have some 5 or 4 questions for you. So I hope you understand these ones. And please write the answer below in the comments to have some great answers. Okay, so there are 4 questions. I may show you again. If you like, you can check them and then write them in the comments below. Okay, so I guess now we talk about what we have learned. Okay. So what we have learned: a liquid evaporates or boils to form gas. A gas condenses to form liquid. Every substance has its own boiling point. If it's necessary, you can even check the chart I showed you behind for each substance and its boiling point. It is very important to learn. And many questions, the trick questions I gave you from behind the previous slide, are related to the chart as well. Okay, so these are the 3 main points. You may write them or you may take screenshots while you're watching the video. Otherwise, it's absolutely fine with me. Okay, so everyone, thank you for listening to my lecture. I hope you enjoyed it. Now, just one more little favor. Please click the subscribe button and the notification bell to get more notifications. And I hope you enjoyed my presentation and I hope you will learn lots from my presentation. Thank you and bye.